My name is Nikhilesh Chawla. I'm the Ramsbrook Professor of Materials Engineering and Associate Dean for Engineering in Indianapolis at Purdue University. Yeah, the stingless bees are actually very interesting, and we got interested in this when one of my graduate students saw a YouTube video of these stingless bees from Australia. And the curious thing about these bees is, and we still haven't figured out why they do this, is that they actually make their comb almost in a spiral fashion. So if you think about a parking structure and you're going up and up and up, that's sort of how they build these combs. The second thing that's different from what we have seen in the Western bee is that they don't make their combs out of hexagonal structures. They're actually sort of like pots, and these pots are all connected to each other, and they actually build this in a spiral. So one of the other interesting things about the T. carbonara, the Australian stingless bee, is that they use their resources in a very systematic and very smart way. So they use these combs to rear their brood, and once the new bees are born, they actually discard those combs. Well, they discard it in a way, but they actually reuse the wax. So they don't have to exert energy to go back into the wild and collect the pollen and so on. So they're very smart about conserving their energy, reusing that wax. And we've noticed this again with the tomography, because what we've noticed is as we look at the layers from bottom to top, eventually you see the bottommost layers are the ones that are used and have been discarded, and the newer layers are actually being constructed almost like a little skyscraper, if you will. And then how they actually make the comb is very analogous to what we are trying to do, we meaning the engineering community, in 3D printing or additive manufacturing, and really trying to conserve and use as little of resources as possible. Now, one of the interesting things about the stingless bees is that as they're building these spirals, they have to take construction principles into consideration, because you can't make a spiral that's freeform. It's essentially just going to crumble. So believe it or not, the bees actually take the wax and make support pillars between the different layers of the comb. And we've only really been able to observe this with X-ray imaging and X-ray tomography, because it's a non-destructive way of looking at the inside of the comb. We don't need to cut it, we don't need to polish it, we don't damage the comb. We put the comb into the machine and we can get the 3D virtual view of what's inside of the comb. So I'll say right off that we're very fortunate to have this kind of sophisticated equipment. This over here is an X-ray microtomography system. It's very analogous to what you might have when you go to the doctor's office with a CAT scan, a computer tomography system, except that this is a very, very high-end version. I mean, we're talking about the resolution of this machine is, we can get to sub-micrometer types of resolutions, so things that are finer than a single hair diameter, for example. So here we actually have the X-ray tube source. It shoots an X-ray. We actually have a honeycomb sample here from Australia. It's the T. carbonara comb, which is a stingless bee, very different from the westernized Apis mellifera. And then the X-rays are collected on a panel display, and this is actually done in a process where we rotate the sample. So in order to get three-dimensional information, we are essentially taking two-dimensional projections at many, many angular increments. So when we get all of these projections, then we use some very sophisticated algorithms to do what's called a filtered back projection algorithm reconstruction, and then you can actually get a virtual three-dimensional data set of whatever you're looking at. In this case, it is a honeycomb. But there are a lot of things that we can learn from the bees in terms of how they work as a team. And I used to be a soccer coach, and one of the most important things about winning is playing as a team, having chemistry, communicating, and the bees do exactly that. They're always building together. They're always actually working as a team. They communicate through their antenna. One of the things that my graduate student Nicole is doing with some of the other Western bees is understanding how bees repair their comb. So she actually purposely made some holes in this comb, and she noticed that the bees, again, as a team, they come in, they clean the surface, and once they clean the surface and they start to collect the wax and start to fill in the defect in the comb. So they actually work together to repair their structures as well.